Your Excellencies, ladies and gentlemen, welcome to the second technical session sponsored by Eradia. Identifying and analysing all technical and non-technical issues can help companies to bring the risks to an acceptable level, reduce the cost of finance, and increase the overall value. The session will highlight some of the advanced risk and hazard management assessment tools and technology-driven practices which helped companies to ensure sustainable growth and de-risking investments.
Ваше превосходительство, дамы и господа, добро пожаловать на вторую техническую сессию, организуемую при поддержке компании Eradia. Выявление и анализ всех технических и нетехнических рисков может помочь компаниям вывести риски на приемлемый уровень, снизить капитальные затраты и повысить общую стоимость производственных активов. На сессии будут освещены передовые инструменты оценки управления рисками, а также представлены технологические практики, которые помогли многим компаниям обеспечить устойчивый рост и повысить инвестиционную привлекательность.
Good idea, ladies and gentlemen. Let me announce the start of the second technical session dedicated to risks. I would say risks and opportunities. And first, I would like to pass the floor to the Director of Operational Effectiveness, or ERG, the ERG company, Oleg Zakharov, Solutions for Improving Production Efficiency and Risk Management in the mining industry. Good day, dear colleagues. Today I would like to discuss let me introduce myself first. I'm really sorry. I represent ERG company. It's a large company based in Kazakhstan. We have different assets: aluminum, iron, coal, and energy assets. In total, we have more than 75,000 workers. And I'm the head of the operational effectiveness or performance department. And within the 5 years, we've been actively involved in developing ERG system. It is a very topical issue for the company. On the slide, we can improve efficiency by different ways. You can invest quickly, reduce the net cost, or to take gradual steps and improving processes day by day with less expenditures, with a higher income. However, it's a long process and it takes even not 1 year, and some companies needs more than 10 years. However, we utilize the best solutions and utilize the equipment through human capacity when we improve our processes from day to day. ERG, I would say a program or the project production started in 2019. I think we are one of the first companies in Kazakhstan who start ERG. The first what we did, of course, we described the production goals, tools, devices, visions, and the way forward. Of course, it's clear that we have identified the tools we are going to focus on. We have 3 missions or the visions. First is to have effective staff to build their capacity. Second, to build the workflow to standardize all processes based on lessons learned, and a non-effective use of equipment, it largely impacts or leads to mistakes. And of course, to set to set or streamline the processes such as measurement, max effectiveness of equipment operations, and the production system, which is called ERG, which has been progressing for the last years. These are the tools we apply. And to introduce, of course, engagement. You have to train, involve, be committed, or make them committed. I mean, their stuff. In the previous slide, if you remember, we saved up to 150 millions by small improvements and changes. And starting from 2019, ideas led. So in 2018, we had 1,000 ideas, and later we had hundred thousands of ideas. For that, we had to start applying and engaging the staff, personnel. Second set of tools is that after 2 years, we built the processes, standardization, standards themselves, and interaction between them, which must be structured clearly, to clearly structure the process. And the third, when we benefit to maximum extent, we start improving operational effectiveness, organizational effectiveness, performance. Of course, the labor performance is one of the key at any manufacturing facility. So I would say we are now on the third stage of ERG, where we apply the maximum number of projects and tools. Of course, there is a need to track or monitor, and then we started implementing the monitoring of changes, comprising from 3 stages. First is the measurement of the system on the ground, when general directors do everyday observations or monitoring. They have to personally assess at the lines. Second, we have developed a guide, an audit of the production system audit, in which we annually evaluate the evolving of the system and where we move forward. And the third, external audit, to know if we have chosen the right way. We have selected Toyota Engineering, a Japanese-based company, which annually audits our production systems, its evaluation based on care principles applied in Toyota. Slow, gradual, planned introduction of different measures and improvements leads to better performance rather than the larger investments, and such single actions may lead to discrepancies or mistakes. Therefore, there is a need to have systematic approaches, and many companies start understanding and engaging. This is the end of my presentation. If you have any questions, I would love to answer them or later. Thank you. I would suggest to ask questions after all presentations. Let's pass to the next speaker. It is really amazing that your company is a big company, pays attention to human resources. Next is Ivan Levinsky, Mechanical Engineer Director, Competent CMT Consulting. Hello, everyone, especially those who didn't attend the previous session. So my presentation is dedicated to geomechanical risks assessment. I will try to do my best in 15 minutes. So you can see who I am. I'm not going to waste time to introduce myself. You can Read yourself. I've been engaged into geomechanics for many years, 15 years. I started from ERCT consulting and now in other company. Geomechanical risk assessment comprises of different elements. One block is the general algorithm to assess the pits. Same for underground mining activities. Risk assessment is a separate section as the block. So one of them is to ensure the resilience. Probably this is a term we use often. However, different disciplines perceive it differently. The word probability, for instance, in medical science, so what risk means. I think I don't need to read them. You can learn yourselves later. But the purpose of the slide is that what is risk? One discipline says it's a probability, likelihood, consequences, and so on. In geomechanics, as a technical science, we review it as an integrity. So geomechanical risks are prescribed in different literature. Applied in different areas and disciplines, and there are special guides or literature which describes the geomechanical risks. The last one is our table book on geomechanics to assess the resilience, so-called Reed Stacy of 2015, a guide to the design of quarry sites, so-called, the translation from English. Another one is the National Mineral Industries, Safety and Health Risk Assessment. As for the methods, there are many small letters, more than 20 methods. Feel free to use any method. So no accounting for taste. However, we applied the risk matrix. I will talk about that later. However, there are a lot of risk assessment methods to be applied in different disciplines or areas, and depending on your taste, I would say. Main reasons behind the risks arousal or occurrence. First reason, I would say, is uncertainty of data we collect in the field, on the ground, and calculation error, which often occur. Whatever we have on the paper or in computers, always not in line with facts, and it's clear. But the question is, to which extent they mismatch. Several examples below the slide. However, in international practice, they apply two methods or combined methods, so-called the quality assessment. So what is quality? Quality of assessment is the use verbal description of the likelihood of certain events and the magnitude of the possible consequences of those events. Then we have quantitative assessment method, which uses numerical values to characterize the likelihood and consequences of an event. And the statement. So rejection of risks doesn't mean we don't have risks. We all know and remember Soviet mentality when we often ignored risks or used to ignore the risks. One cannot deny or reject existence of risks. Only if we accept, we can manage those risks. Other methods of maturity assessment or maturity chart, as you see, how companies assess their materials industry risk management. By the way, Shell, the oil industry, have developed this guide, which moved, I would say, to mining industry charts to be used and developed or designed by Shell. Each company can assess itself or ask external auditor or consultant to evaluate the performance of any company or on which stage the company is in terms of risk assessment, which I believe is a good startup with risks. So let me now dissolute who are bored. In geomechanics, we call risk to multiply the likelihood of an event and its consequences. Assume, let's have an element of likelihood or likelihood element. We can calculate in geomechanics. We can assess both quantitative or qualitative. On the diagram, you can see an area in the bottom line. You can see that with stripes, green and red and blue. You can see the stroke area, red and blue. It's a likelihood. It's not that we always use geomechanics in calculating the measuring so-called sustainability of deposits or reserves. So-called it's better than less, another parameter to assess the likelihood. Uncertainty can impact your outcomes in a way that it will become even worse with the higher risks related to reserves. Same graphics, red color is a likelihood of collapse, for instance, in red. There are other methods to assess the likelihood of risks. Key methods is represented on the slide. It's a Monte Carlo method. Just for the sake of reference, there are other methods to assess the likelihood of a risk. Another component of the risk, the consequences or the severity. Which is reflected, by the way, in Russian literature, assessed in value, a monetary value. So we can assess the severity of consequences and select options of the negative event occurrence. Matrix-based risk assessment or risk matrix to find the cross-cutting point and to evaluate the risk level, acceptable or not acceptable, if we talk about particular risks and what to do with that risk. In my opinion, we have to identify the level of risk and take actions. We call them response measures on how we respond to those risks, and often we have very low risks. We cannot exclude risks. However, we can minimize those risks at acceptable levels. As low as reasonably practicable, so-called ALARP. Reasonable practicable. If an event leads to risk mitigation or reduction, or we reduce the impact, they become higher in terms of monetary value. So you simply have to abandon those options. You should not apply everything what is written. Few case studies. We draft this list of risks, factors, levels, and provide for solutions to address them. Such graphics can also help to identify the impact or effect. It's not at a time-dependent scheme. It's a scheme that after a certain month you can reach the level, the required target level or required level. Practical application of those assessments, so-called zoning. Zoning can comprise of two elements. According to the level of geomechanical risks. It means maybe we have to focus or improve monitoring. Or it may happen. And then we can draft a zoning map specific to the site. And we can see that something will happen and you have to warn the population or the workers. We recommend to apply it. And we do it, by the way. And this is almost the last slide. Regulatory framework. There are different types of activities that contribute to risk reduction, so-called stabilized method aimed at improving the sites and so on, or the combination of those methods. Here are our contact details. Please feel free to contact at any time or in the hall. Thank you.
Thank you. I invite Mr. Stepan Olegovich Volkov, Metso company representatives, for the next presentation, hydrometallurgy, the next topic. Good afternoon, dear colleagues. Very pleasant to see still high interest to the topic of today's discussion. And before starting my presentation, I would like to address a question to the audience. Have you ever thought what factors contribute to the gold mining for optimization of the processes and for further optimizations, like decreasing of operational expenses, improving ecological indicators? What lies in the reason of that? If we take this as the reason, first of all, this could be number one. This is our depletion. This is the necessity of decreased operational expenditures. If there are solutions, number one was just a less number of ore available. That's then modernization, other type of solutions that allow to occupy less space and decrease footprint. In fact, rich deposits now almost disappeared. Now that's less rich deposits remain, and they are reprocessed. In fact, I would like to characterize our company and say a few words about what we do. To begin, we are leaders in supply of technological solutions, and the company understands that need and comprehensive approach in developing a certain or this or that technological approaches, schemes, and or technological solutions. Our company owns know-how, knowledge, expertise, not only in developing of the processes, but with the whole complex of necessary activities, including research, use of knowledge, data, technological research. If you look at this block or scheme, you may see that our company make a turnkey supply for the company in developing profitable and efficient methods of processing of each site, or from technological islands, they call. But because of lack of time, I cannot go into each item or talk about key issues that autoclave leaching, bio leaching, and the burning approach and optimization of the processes. In fact, I'm ready to discuss it, but today I'm talking about methods that could be optimized for desorption or different type of leaching processes in this regard. In fact, I can give slightly more descriptions, but before we go move to the different type of equipment use, I need to tell a few words that all development cannot be possible without our research center, which not only provide testing samples, but helps develop, create innovation, develop innovation, modernize existing technological solutions, and with use of equipment, corrosion stability of material, worn out stability of the material test, hydrometallurgy, flotational test, crushing, pulverizing, testing. This is all part of our company. We have staff and we have specialists based on our technological department division, which is actually working on a full supply of technological documentation, starting from how to lay out parts of equipment and enterprise up to using BID diagrams. And we have quite extensive experience in modernization of current and creation of a new I would say enterprises that plan to work and ensure most optimal costs in terms of OPEX and minimum CAPEX. So, and it is also important to know that our company, in principle, is invests into new products and develops, and we invest over 100 millions into the research. Our company, in the bank of our company, we have patented more than 8,000 different patents for technologies and solutions. And now I want to go specifically talk about the topic of today's discussion, about modernization of those parts of production which are of the most important. First of all, sorption, leaching. What is the key peculiarity of our units compared to standard leaching device? First of all, modules. We provide a solution that is prepared and ready and equipped with all necessary equipment in modules, and which in principle is taking very little space in terms of location, and does have certain modifications. Speaking larger about type of sorption leaching facility, this is specifically developed for gold industry. What is the main difference in this solution? That we have a system of automation for this particular process. We have process of optimization. There are special elements that allow to optimize process of mixing of ore, decrease worn out in the of coal, and I will show you the specific sensors. Solutions are well prepared. Speaking about APC contract that puts together different things and from different sources and trying to mix it up, but that's create a difference. But we provide one interface, one device that with all necessary spare part supply and less time needed for collection assembly, and we provide technological guarantee on our equipment in terms of gold extraction and its maintenance and use. Our units are supplied with special meters and special sensors to help optimize the process and focus on several elements. One element we call the flow bottom. This is our uneven bottom that allows to increase speed of mixing, and with that there is no need in actually establishing strong mixers. It means that it is possible to decrease power which is needed for mixers. Also, it decreases energy consumption and coal abrasion, and also actually decreases the cost. Sense octop, another approach which actually optimizes the mixing and collection of hard pieces in the lower part of the react, and provide unique way to increase the volume, effective volume of the reactor. And in principle, we can talk about sub-products which come as a part of a solution, such as carbo sense emitter sensor tracking the carbon, the coal in it. CIL optimizer allows, for example, to automate control of flows and work with carbon sense meter. And simulator and analyzers for CIL carbon and leach processes. Now, how they help? On this slide, you can see that if after special bottom is used, as you see, it's a we call Hydra wing type. It looks like our type of bottom and is used in the format that you can see on the slide. We use different type of engines, and in fact, the smaller engines actually reach same results, and our solution allows to have a better mixture than without our solution. Carbon sense. This allows to decrease coal abrasion and gives certain benefits in sorption, leaching, and decreases operational costs and improves safety. Sense. This is actually how it looks inside the reactor and allows to track and see how it works. And on the picture you see that this is not only our reactor that is produced, we can actually optimize existing companies that actually use sorption leaching. And some enterprises actually now avoided the process of sand accumulation and with the use of our approaches. In addition to that, additional processes. Apologize. Another one of the reasons that I forgot to mention is preg-robbing process. This is a standard process. Preg-robbing is actually burning, but burning is quite expensive solution that requires additional capital costs. And then who will be the supply? Where do you bring sulfuric acid? Where do you carry it? Who will use it? Is there a need in building additional railroad? Yeah. But we have a high-tech solution, high-tech, HITECC. In fact, we can avoid pre-grubbing effect with using that, because the principle of high-tech approach, this is similar to CIL process working in two modes, desorption and special carbon leach, or absorption leaching. There is a heat, such a desorption of organic coal on the hot end. On the cold end, there is a sorption for the fresh coal. Similar technology is applied here, but you need to pay attention that use of this technology, in order to check it, the test is needed. First of all, it has to define pre-grubbing percentage or effect which exists. In our enterprise, where we implemented such solution, that was Suzdal, ethical company, that allowed them to decrease losses of gold with organic coal or carbon elution process. We can provide any type of elution or desorption techniques depending on preferences, or one better matching in terms of COPEX. We work in both ARL and Zadra company approaches. And this our solution is module based. It actually includes all type of equipment blocks necessary for desorption process, which is our actual separation of. There is equipment for acid washing, for elution, heat exchanging, regeneration of carbon, electrolysis, and technologies. Not technologies, but equipment for a golden room. I won't just list all of that equipment to save time, but our solution is, in fact, a module-based, which allows to, first of all, decrease necessary space needed to place this unit, because standard and trends on implementation of desorption is have huge facility, a workshop with the pieces of equipment all over the place. And capex on construction is quite substantial, which is a regular way. And in our mode, we can put everything in a properly designed mode to reach less carbon erosion, abrasion, avoid issues with the pumping carbon liquids. And Mashun Masara company in Saudi Arabia actually applies this type of approach. We put a 4.5 ton device first for testing, and then we have this 4.5 ton for illusion on coal on carbon, and now we are using 12,000 tons. It's signed another agreement. No, apologies. It's pretty tired. 12 ton of carbon now load. We have a signed agreement and we're working with them. And they selected us because they have experience with different standards, standard processing. And our process actually allowed to decrease reagent use, get higher rate of elution, abrasion of carbon to be decreased, and simplicity of work with automation process. So this is, I think I got you tired by the end of the day. This is the end of my presentation. Thank you for your attention. Yes, I wanted to say that questions will be. Your microphone didn't work. Sorry, I didn't turn it. It didn't turn on. Shall we answer questions now, or shall we put it in the end? I suggest to have another presentation. Then I may have all presentations made, and then move to that. So that was Metso company. Thank you for your presentations. This is not only a large company, but is always on the edge of the progress. Adilbek Rustemov is invited. Draslovka Holding Company. Topic is very interesting.
Добрый день, уважаемые коллеги. Меня зовут Адилбек, технологический лидер по Евразии.
Good day, dear colleagues. Draslovka Company. My name is Adilbek Rustemov. I would like to thank organizers of this event. And thank you for the opportunity to speak. As one well-known interpreter noted, innovation is what differentiates leaders and those who are catching behind. This is part of my presentation, but before going into the details, I would like to briefly touch upon Draslovka Company. I think majority of those who are sitting here didn't hear about Draslovka Company. This company is one of the largest producer of special chemistry in the world. And since 2021, the company is the largest cyanide producer in the world, after company have purchased cyanide business from Chemex, US company. Cyanide is only one area of our company work. The second largest of the Draslovka company is glycine leaching technology, and this is what I would like to tell you about. Briefly speaking, glycine leaching is a technology, is a replacement of cyanide which is highly toxic, very expensive, and dangerous hazardous element, and replacing it with much safer, a less non-toxic and cheaper element called glycine. So let's go step by step. Glycine enrich technology. First of all, what is glycine? This is non-toxic chemical, fully decomposing biologically. If glycine, like if you have an incident and you spill glycine somewhere in the environment, it will not damage or it will not cause any negative or adverse effect to the environment because this is biologically decomposing. This is an actual amino acid quite often used as a food additive. Like if you go to the drugstore, you can find this, little things to improve, like sport, or emotional condition, and actually this is some pills for which is food additives. Glycine can selectively leach both non-ferrous and precious metals out of the total composition, and also this is a recirculated, a regeneratable component, which could be up to 50% be recirculated and recycled if you have proper recycling system for the water, recycled water. We have 4 products: GlyCat, GlyLeach, GlyM, and GT trademark. The first 2, GlyCat and GlyLeach, are our main products, which are already commercially successful in different mines all over the world. The 2 more products, GlyM and GT, are currently being developed. And in this presentation, I will speak only about the first 2, GlyCat and GlyLeach. What is GlyCat? GlyCat is actually our new revolutionary technology of leaching of gold, which includes glycine and low concentration of cyanide, sodium cyanide, for selective gold leaching, providing considerable decrease of production costs and ecological benefits. What actually gives? This gives a capacity of decrease of cyanide use up to 80%, or down to 80%. Depending on your technology and mineralogy of your mine, there is a great capacity to exclude costs on detoxification and on detox. And there is a capacity on extraction of gold or copper, depending on minerals. Plus, again, depending on your mineralogy, if you have such content of mercury, of arsenic in base ore, there is a capacity to decrease dissolving of these elements in leaching process. There are 4 benefits actually bring to considerable decrease of operational costs. We talk about 50% and improving ESG rating. Another benefits of GlyCat, it doesn't require capex with a base scenario. If glycine comes to the tailing dam, so 50% of glycine is returned back. If you want glycine to be recycled up to 90%, certain capex will be required to put special equipment for recycling of this element, and this actually will decrease OPEX even higher, but this is one optional function. Also, there is a capacity to leach copper if it is feasible, if there is a feasible content of copper in the solution. This technology is also easily configured with carbon leach or CIL or CIP technologies without any modifications. Also, this technology one of the strengths of this technology is that any time during testing of the technologies and actually during the use of this technology, in any situation you can stop using this process without risks and actually go back to your main original technology anytime. The second product is GlyLeach. I won't go into big details, but this is actually a leaching process providing simple and selective method of extraction of of non-ferrous and primarily non-ferrous and then precious metals. Again, this is economic, safe of extraction of sulfides, copper, nickel, and cobalt. Products have strong ESG effect. First of all, decreasing content of cyanides and arsenic in treatment waste water and in tailings, including Swiss International Cyanide Management Code (ICMC). Content of cyanide in tailing should be below 50 parts per million ppm. With our technologies, you can reach actually content even like to 10 or even 5 parts per million, depending on mineralogy, meaning much lower the benchmark. Also, it can decrease HCN, which is the like in the plant that use glycat technology. In fact, you don't feel the cyanide smell. That is different because those who work in enrichment, you understand, no matter how strong your isolate equipment, this specific smell actually remains. And there is some, in atmospheric air, there is certain content of this acid that you can feel. But in this case, you don't feel it. So we're talking about hydrocyanic acid. In fact, this type of cyanide content could be also decreased with as a part of toxic combination in tailings. So this is our what you see in this trend. This is order of our interaction with the client. First of all, we conduct after engagement. We conduct lab research. Our main lab is located in Perth, Australia. If you have CIP or CIL, only what you need to send 5 to 10 kilogram of your material, your sample you send to the Perth. Within a month or two, we conduct research. We send you a report. The cost of this work is about $10,000 US. We don't earn revenues on industrial or lab testing. This is just cost recovery, including time, labor, and material cost only. But you after that, you get report. And if results are positive, using that, you can move to the second phase, which is optimization. This is, again, optional technology. Some of our clients go to the optimization, mean additional lab testing and additional studies. But some clients move right away to the phase 3, skipping phase 2, which is pilot testing right away. We have a special equipment, the pilot equipment, which could be used both in Perth, West Australia, or it could be shipped to any mine to deliver it on-site and actually do the testing on-site. If there is a positive result, we can sign commercial and licensing agreement, and then we move on to the industrial testing. Industrial testing is, speaking honestly, this is actual implementation of technology. The final one. And after industrial testing, we usually, if there is a positive outcome, we sign licensing contract. And on this slide, you can see one of the case. We don't indicate the name of the company because we have NDA and non-disclosure agreement. Here you see the leaching of flotation concentrate, in particular. Use a glycat cyanide leaching. We decreased cyanide use by 75%, improved extraction of gold by 5.4%, and 39% of silver extraction was increased. In standard leaching at this enterprise, consumption of cyanide was 10 kilogram per ton of flotational concentrate. Our technology allowed to decrease down to 2.5 kilograms per ton of flotational concentrate. The next case actually shows how our technology, impacts OPEX of the enterprise.
This is the real case and impact to OPEX. Glycat improved operational expenditures, reduction up to 30% on the CIL. The first column are the OPEX before glycat 40% of expenditures were the share of procurement of cyanide, which totaled $20 million. After the introduction of our technologies, the saving totaled 14 million USD, 75% of cyanide consumption. Then we have 2 million additional cost to procure glycine. In addition, we had a saving on detectification, and the last column is additional costs or the payments for the use of license. OPEX in total reduced up to 30%, as you see, by applying this technology, which resulted in reduction. It's not a commercial technology we have developed and we never applied. In practice, we have started applying these technologies commercially in a Barrick Gold company. Barrick Gold. Despite we have produced this technology 1.5 years ago in Tanzania, so-called the Barrick company in Tanzania. In first case, we have applied it by an Iraq LLC in Mongolia, where we succeeded in reducing cyanide consumption up to 70%. So the first case in Tanzania, the global technical assignment has been completed. It's the world's first commercial use. It was a glycat heap leaching, and industrial tests lasting 18 months was successfully completed at Ayuchu Tails in Zimbabwe. This is feedback from our customers. In conclusion, if you want to improve the income or the revenues of your company, we suggest to lab test in Australia, in Perth City. Thank you for attention. You can find my contact details. Later, you can ask questions, or afterwards, you can scan a QR code later. Please feel free to contact at any time. Thank you. So next, I would like to invite Mr. Rogalski, Senior Geologist of Kyrgyz Community Society of Subsoil Use. Hello, everyone. Hello, everyone, again. I was traveling to attend this forum when I saw the topic of the forum on MINEX. To talk about the driver of mining sector of Kyrgyzstan and Central Asia as a whole, and thinking about the drivers or triggers in mining sector is the most acute or challenging and in demand. In my experience, if you look at the processes that take place in Russia, such a trigger, a breakthrough, was the evaluation of man-made, so-called man-made deposits. And the Kyrgyz Republic can have a revolutionary breakdown as soon as country may or can start, or if the country starts managing or developing such man-made deposits, or the technogenic. So the first question is, what is man-made deposits? Is a concentration, of course. Man-made deposits are the accumulations, as I said, of mineral substances. The quantity and the quality of the mineral raw materials contained therein are suitable for economically viable use. You know that there are two types of man-made deposits. First, anthropogenic mineral formations are accumulations of mineral substances separated from the massive and stored as waste from mining. And the second is a natural man-made, natural man-made objects, which are the minerals objects not separated from the massive, left at previously developed deposits in the form of pillars, undeveloped production blocks, and landfills. This is a very, very short scheme of such deposits, or the waste deposits, which is equally relates to mining sector, metallurgy, production, fuel industry, and chemical industry. All classification types you can see on the scheme, starting from extraction, enrichment, processing, at the waste, at reservoirs, or slags, slums, and enriched mineral elements. We all know that these are slugs or slums in metallurgy. First of all, the most interesting sector we all know is the gold mining sector. Why? Because the gold has a tendency towards increase in prices. So it's highly demanded metal, I would say. And it largely depends on time. And by concentration, by partially developed gold deposits, or the facilities are now on all the targets, and promising, let's say promising in terms of exploitation and developing, redeveloping of those deposits. On the slide you can see the classification by groups, types, subgroups, subtypes, and so on. So-called man-made, Kolyma, Chukotka region, enrichment tails, also the sprinklers, gravitation of cyanide separation, and so on. So there are regions which were developed in the past in Russia. I mean, the gold, it means mining sites, but now they're redeveloped again. Kyrgyzstan holds also good capacity in the antimony in Haydarkan, Sarıca. So these are the capacities in Kyrgyzstan. So those antimony deposits are of very high value. And I was glad to see in the agenda of the forum that we discussed the use of Kumtor Gold Mining Company tails, Aktuz deposit, and Kekisai deposit. I would say it's a God-gifted deposits, which may become a driver, a breakthrough in energy transition. As my presentation was translated, energy transition. Talking about rock dumps, before it was off-sheet reservoirs can be used in a condensated manner. And talking about those deposits, yes, in terms of conditions or geographical position, it's difficult to reach them, I would say, but there are good systems of stacks maybe can be used. The scheme itself, I'm a geologist and can share some knowledge. There are certain specifics in assessing geological reservoirs. I mean the tails, man-made resources, I would say, or raw material, sorry. Which relates to the second classification, as I said, and how how can we evaluate and which parameters we can apply if we mean the man-made deposits tails. So these are recommendations, as I said, and can be widely used. By Kyrgyzstan as well, as I said. So three types, as I said: technogenic pillar complex, dump complex, and tailings ponds. There are excellent examples that Kyrgyzstan on developing, building the deposits, and to have economically reasonable products, I say, without extra capex or opex, such as exploration of the deposit, other side, infrastructure building, and so on. So it will not require huge investments briefly. All those associated expenditures. Man-made deposits are ready. It's simple. Just come and develop and build. Benefits. So there are benefits in place, ready-made benefits. Developing of man-made deposits will have good positive environmental effect. Will improve environment itself around the ecosystem, and liquidation of new sources. So the tails are there constructed, so there is no need to build new ones. So first, of course, improvement of ecological situation, as I said. Then preservation of depleting mineral resources in the subsoil, and the reduction of the negative impact on the environment and the population as it mitigate environmental impact by modernization of existing processing complexes, improving, I was extracting metals, precious metals, and so on. All will contribute to the reduction of waste volumes and so on, or discharges and various emissions. Furthermore, the main environmental consequences of industrial mining that cannot be prevented even by developing man-made deposits. One cannot do anything. Recultivation or reprocessing of those deposits, it means we can have parks and trees planted and the soil cover disturbed by the activities of the mining enterprise and alerted natural landscape, as I said, and the natural environment polluted during the activities of the mining enterprise due to the movement of ore mass, crushing of ores, use of flotation reagents, manifestations of oxidation processes, and weathering. And in line with the topic of MINEX Forum in Central Asia, and after reading an announcement that Kumtor is planning to reprocess 120 tons of gold at the Kumtor Gold Mining Company's tail, unfortunately, we never heard a presentation or the heritage of uranium tails in the Kyrgyz Republic. I was expecting to hear that presentation. And during that announcement, there was to develop tails in one of the deposits of the Kyrgyz Republic. Kyrgyzstan is really rich in deposits and mineral resources. Indeed, Kyrgyzstan must use its resources, natural resources, for the benefit of the future population, keeping in mind the future population and keeping in mind the last legislative changes in the Russian Federation. As a best practice can be used, we have a lot of new laws and acts that enable, that provides the grounds, in other words, to rename or name used tails as a new deposits. Or those, let's say, of the balanced deposits. And we have a new word, so-called second reopening, so-called fluorine reopening term used in Russian language now. In Yakutia, one of the regions in Russia, they have such facility, very mysterious name. The deposit is called, and a mysterious name, in Gulag. So now we have evidences of so-called the fluorine reopening. It is very promising maybe for the Kyrgyz geological community. Rare ore metals. They're highly demanded, of course, and Russia is rich with such minerals. So these are works of VIMs, private companies, when they have reassessed those deposits, extremely developed, let's say, or processed, closed mines. And you can find on the map, so those reused deposits, different metals, zirconium, quartz, and so on. So they're all demanded in producing electronic devices or in any technological processes. They're widely used, I mean those metals. And of course, the government has excellent opportunity now to rebuild the sector. And the last slide, my last slide, and the purpose of my presentation. So there are specific figures. So this is statistics for the last 2 years. So the involvement of useful components of man-made raw materials already accounted for 10 trillion rubles in the mining industry of Russia. I mentioned that you don't need to build roads, redevelop, or build infrastructure. So the receipt of additional taxes in the Russian budget from the receipt of products from components of man-made deposits amounted to about 20 billion rubles per year. And the annual growth of Russia's GDP due to the development of man-made deposits is about 2 trillion rubles per year. And the reduction of Russia's budget expenditures on additional researches, assessment, and exploration of new deposits of solid minerals is at least 250 billion rubles per year, just because they have changed their approaches in reassessing man-made deposits of mineral resources. Thank you for your attention. And we are sharing our success stories with Kyrgyzstan, and Kyrgyzstan is my motherland. I was born here. I hope Kyrgyzstan soon will start. We have one more presentation. Khulov Mikhail Sergeyevich, Eradia Company.
Okay, a radio company. The company was formed in 1915. The capacity and warehouses of explosive materials located in Isakata district of Choi Oblast, province not far from Bishkek. Main task is blasting for industrial purposes. Currently, activity is focused on 3 workshops. One has non-electric initialization means, workshop number 2, making pipes, and number 3 is the electronic detonator production. Eradia company vision to be vertically integrated company to product high-tech production for dynamic development of mining industry. Mission to create high-tech products in the area of industrial blasting to be safe, ecological, and competitive. The goal, localization in the Kyrgyz Republic of full cycle of high technology production of industrial blasting means. The key success factors: we are the only enterprise in Central Asia that produced blasting materials and blasting means. Competence on production of digital means of explosions and a new generation of equipment. We're open for the market. Open global geopolitical economic change in the world gives new opportunity. Localization in the Kyrgyz Republic of main elements allow us to develop. We provide 2 type of products. Dolphin type electronic detonators and non-electric systems of initiation. Again, that could be based on wires or no wires. This year we started working with electronic detonation devices. Now we have fully automated line on production of electronic detonators, even though that we haven't got to the full capacity, but now we are already implementing 2 orders for electronic detonation devices or remote control devices. Along with this, there is a production of non-electric means of control under Dolphin trademark. Until today, history of the company we could describe 4 main elements of the company work. In 2015, company was formed. Transportation, sales of control devices, start of accumulation of competencies in year 2018. Own assembly of non-electric means of bought and purchased pieces. 2023, own production of explosive wave pipe for non-electric means. 2024, own production of electronic control systems. Our plans for upcoming 3 years include the following. Already now we are working on implementation projects to improve productivity in terms of creation of non-electric control means, and we have planned construction of plant for capsule detonator production with full cycle production at the territory of Kyrgyz Republic. Apart from that, we want to jointly with the educational institutions of the Kyrgyz Republic organize scientific research base and the enterprise with attracting students on the profession, on the specialty explosives and blasting works to improve technology and to work on currently available products and development of new products. While humanity extracts useful resources, erects or disassembles various facilities, builds tunnels and other objects, our products will be in demand. We have blasting solutions for you. Thank you for your attention.
Exploring the richness under Earth. Before I proceed with questions, we have Mr. Talgat Dushanaliv, Kuntargol Deputy Manager. Talgat, you had a question, right? Let us start with you. Please be seated. You can ask from there. Hello, everyone. I would like to discuss the modern trends and challenges in hydrometeorology. In your opinion, which are the most promising technologies and how to address those environmental challenges rational when developing, let's say, difficult deposits? I will appreciate your tips and advices. Thank you. I believe there is no one unique answer. Each deposit is characterized by its own mineralization, availability of density of ore. It can be strong or weak, dense. Regardless of my recommendation or unified, or there is no unique recipe for that. And there is no one understanding. And before I answer which method is best used, you have to test and apply other different options. Each method or refractory ore, gold, behavior of gold, I would say, or which method can be applied, depending on the ore, or maybe it's a double refractory ore, what if? And based on tests, only then you can make a final conclusion. Which method to use better to process refractory ore, for instance. Refractory. Another thing is every technology has shortages and benefits and advantages in terms of savings or environmentally friendly method. Each production line can be cured. Let's say roasting, in other words. Our company has the entire capacity and technological capacities on sulfuric acid roasting, for instance. Dioxide of sulfur, for instance, is used. You will never think about it. Much depends on the competences, test works, and much depends on the specific requirements of a client or the customer. And it also depends on possibilities, closeness, or proximity of workshops or the available technologies, in terms of modernization. Every case is unique. Unfortunately, we can't say there is one universal recipe for that. Thank you. May I also contribute? I'm not an enricher, I'm a geomechanic. A small comment. A few months ago, I attended a conference. Stepan, you remember we attended together. The conference took place in Kazakhstan, Ust-Kamenogorsk city. One company made a presentation on ore enrichment, and they also invited us to visit their facilities. They're open. I can contact them. You can visit. Then we had representative from one of the factories in Uzbekistan on how they enrich the mining ore. I would just advise you, please feel free to exchange experience and knowledge. That's what I would advise you. And my part,
to answer the question, or I would like to continue answering the question to Tolgat. I will add from myself the technologist work. Excuse me. Okay, let me finish my statement. The work of a technologist is very similar to work of a doctor, or is like a patient. You need to select, do proper diagnostic tests, and take all necessary tests and examine well and just put a diagnosis. Because some decisions might be economical, not physical or feasible, but methods are always there. So you need to first define. I would like to also add, I would agree, I actually agree with you, Dmitry, that first you have to focus on tests. And after this testing, then you define what methods are actually applicable, which work, first of all, then see which of them are feasible. Then you can select which enterprises to see, who to exchange with, because it could be the case when I do have wide experience, vast experience. Like, because somebody comes to enterprise, they like it, and then when it comes to testing, unfortunately, extraction was very small, and they ask, why is this happening so? Well, but you insisted on that particular enterprise, we would recommend a different one, but it works with them. Why it's not working well with us? That's because each deposit is unique. There is no way that same results you get everywhere officially from any enterprise or any deposits. So it's very specific, site-specific. Thank you. Some time ago we made analysis of risk. For the project we were preparing presentation, we found statistics from around 1,000 projects. And the statistics task was to understand why mining projects do not reach productivity put in feasibility study originally of the owners, diagrams and plans, and especially if they're from the West. And then we found out there could be technical reasons, like geology, technological issues, or equipment is not a correct one taken, or mining or extraction part was not well done. But statistics also indicated the following: there were no reasons indicated that that a project didn't get to its productivity and efficiency because of a lack of qualified staff. This was not indicated in any statistic, but I believe the topic is very important and people are very important. So my question was to RG company, Oleg, how do you train staff? How do you educate young people? Well, now Oleg speaking, we have a corporate university working with the RG company, which in fact in fact, we have many different projects. We work with a number of technical academies. There is Academy of Leadership, and each academy, like there is a mining academy, metallurgy academy. I mean, all areas of the company work. There is a training of staff on each of this area. Plus, several years ago, we started and rolled out classical tool of the lean production. It's called TWI, fashionable. Now, back in old times, Soviet Union, we used classical, our economy approach, and things that were lost or forgotten in the past, and sometimes we lose people with that, and this is one of the risks. Yes, one of the risks of developing new projects is lack of staff, because I think it's in any country this issue is quite topical. Dear colleagues, if you have any questions, please raise your hand. We have microphones. Do we have a microphone? Yes. Can they ask questions from where they sit? Yes, while you prepare questions, I have a question to Ivan. Ivan, in your presentation, it was written, fix it when it fails or when it breaks. Is this approach okay for geomechanics? Thank you for your question. In fact, in the presentation, it's a very good question. In presentation, the focus one was and the following. In the past, it was fix it, when it breaks, you fix it. I mean, that's many companies dealing with. I mean, you start coping with consequences of when something has happened, like a machine broke or a vehicle broke, and then you start fixing it. That was common approach. But lately there were a number of accidents or incidents in the company, which are different, which are very unpleasant or even dangerous. And then thinking started: why don't we do something to make sure it doesn't break? Or, of course, you cannot ensure that everything perfectly works and no failures with equipment, but nothing breaks. It's not possible, but you still can foresee and be more proactive. This is a request of the time. Use methodology of prevention, an approach that allows to think up front, to find out where these cases could take place. And of course, you cannot exclude everything, but you can actually focus those. In fact, this is not my words, but this is from smart books, which I have read. Thank you. Colleagues, any questions? Raise your hands. I have a question to Draslovka company representative, to Adilbek. Glycine and cyanide in the leaching processes. I haven't heard about these methods in the past, and I wanted to ask you a question. Let's say these reagents that I use, you say it allows to improve extraction, like extraction of gold and other precious metals. You noted some increase per case. Did you make a research? Did you try it to the resistant ores, or how does it work with different type of ores of this set of reagents? Thank you for your question. In fact, our technology is best working with this. If we take estimate of how cyanide could be decreased with a certain type of ores, that could be up to 90%. Or a free milling, which is easily extracted, or that could be 60%. In fact, our technology works better as refractory ores, especially those with a copper content, because copper actually absorbs cyanide. And chemistry, in this case, work in such a way that copper is, first of all, is being leached with the help of glycine. In fact, cheap glycine is actually consuming ore, which we usually don't need. And the remaining part of cyanide in this solution is used only for gold. And expensive cyanide goes for expensive metal, for gold, because glycine extracts a copper before the cyanide. And this is why our technology works better with refractory ores. How about non-refractory? How about sulfur? You mean sulfur, solution of sulfur? Yeah, there's a sulfide ores, right? There is a sulfur that encapsulated. Well, sulfur, iron, zinc, some non-ferrous metals, pyrite leaching. In fact, in this case, glycine chemically works in such a way that it first takes out for itself those elements. In presentation, there was a case with flotation concentrate, and our technology was successfully working with flotation concentrates. Why? Because there are usually a lot of sulfur, because pyrite and other elements are abundant, and in fact we can decrease up to 90% use of cyanide in this type of flotational solutions. I have 10 of questions as technologists, but I think we need to have a special discussion on that. A question to Valery Rogelsky. Valery, you made analysis of different technogenic objects. Which object, to your mind, is the most attractive for investments out of those you listed? Well, out of the group of most attractive, the most attractives are placers, technogenic placers, where drug machine can work, because previously it was doing a dirty work. The technology of placer washing with a drag that actually leaves a lot of metal behind in silt, in sediments, and in the walls and banks. And speaking about Kyrgyzstan, this particular approach, where there are many polymetallic or complex ores, this is the case. In Kazakhstan, we may talk about Kaz zinc objects, Ritter Sokolny tailings, Vasilkovskaya deposits, which are very topical. In Kyrgyzstan, Aktus and Kultisai, which were mentioned and look at more promising, and Kadamjai ores, which I started from. It was containing gold that previously could not be extracted. I mean, the work was done back from 1930s, and then tailings of Kadamjai, antimony combinate, south of the country. There are different polymetals, and in fact, that object that could be, in demand tomorrow. Thank you. More questions, colleagues? Okay, we have raised hand. I see it. Good evening, dear guests. Norgol Pozarkolova, Kyrgyz Geological Service. I have a question to Adilbek Rustemov. You mentioned that in order to conduct calculation and do the justification whether this methodology of leaching is applicable for this or that rock, and certain testing is required to be made in Australia. The question is this type of testing possible in the labs located closer to our country, nearby? Or do you anticipate opening your lab in the future in this territory? Thank you. Thank you for your question, because this is a very important question. I didn't note in my presentation, but I should have. We do have experience of conducting studies and lab testing at mines. If you have metallurgy research lab on mine, on site, we can do it at your place, but this will be much more expensive. More likely because Australian specialists will need to come to you, live there, conduct the study, and that this is possible, but this is more expensive. Thank you. I have another question to Mr. Stepan Volkov. In your presentation, I have seen that the diagram, one of the boxes was dehazardization. I think we're talking about cyanide, and because that was your presentation about what technology do you provide to decrease the hazard? Usually we use a standard TENCO type standard, but we can use chlorination and different technologies depending what. But ENCO technologies usually that is requested by EU companies, or whatever our customer is willing. But our company is actually has a unique solution on additional thiocyanide. improvement. We're talking about bacteriological decomposition that allows to get technical water, like whether used for biox, if for biox, or even useful for flotation. The cyanides getting back in flotation, in fact, stop the whole process. But this technology allows to take away cyanide and recirculate water from this process, bring it back to the. Any more questions? If there are no questions, there is one. Good afternoon, dear colleagues. Kento Research Center, Amana Manglidiev, Senior Technologist. My question is to Stepan Volkov. Historically, at Kumtor mine site, the situation was formed as follows. Over the period of the work, that extraction or recovery was around 79% overall. First of all, it depended on pre-grouping effect and type of refractory ores. And now there is a dilemma on processing of tailing at Kumtor. Options, there are either build a new tailing to process, rework previous tails, or in order to get higher recovery, up to 75% from tail, 0.8 gram per ton average concentration in tailings, and it should be 0.2 grams per ton for utilization of the tails and put it back or reverse in underground, or produce construction materials for household use as utilization. Question to Metso. Do you have such technology, or could you offer such technology with high recovery, like 75% extraction, if you take samples from Kumtor? Yes. I cannot tell many details, but what our companies actually have done testing on different type of methods, including autoclave leaching and burning bio-leaching process, which actually gave us number of numbers. We can reach up to 80% if we take tailings. Tailings which are laying for like a certain time over and at Kumtor. If you speak about more details on data, I can't really disclose them currently, but we have reached better effect from the through production. We actually get to the point that some methods are actually could be more selective. Decisions have not been taken yet which methods Kumtor company will select. They not decision taken yet, because first of all, I cannot talk about this without permission from Kumtor company and have this discussion before they take decision. I think you better ask representatives from Kumtor, not myself, because they have the numbers.
Yeah, thank you for this interesting question. Tails processing and tailing is very acute issue because most companies now come back to developing tails. If no other questions, let me pass the floor to Arkady Rogalsky to present investment projects. Hello, colleagues. I think this is the last presentation. The presentation is prepared by Kyrgyz Geology by Mr. Murad, but unfortunately he's on business trip and he asked me to present on to how to process rare earth metals. So what is state-owned enterprise Kyrgyz Geology? It has been established on the 23rd April 2021 as of the government decree. In fact, we have started our operation. So the history is that it starts from 1938 when the geological service was established. Comprises from 6 companies: North Kyrgyz Geological Expedition, Kyrgyz Methodological Expedition, South Kyrgyz Geological Expedition, Kyrgyz Geophysics Expedition, and Kyrgyz Complex Hydrological Expedition, and Bishkek Expedition. For instance, one of these expeditions, let's say, is the supplier of geological equipment for entire Central Asia, Kyrgyz Geological Expertise. So the expedition has methodological expedition is separate agency to develop legislation. I would say the normative acts that regulates the entire life of the Kyrgyz geology. It also processes the mass data and data, I mean, in possession of the Kyrgyz geology. Kyrgyz Geophysics Expedition is a very unique enterprise. In fact, geophysics expedition is one of the main manufacturer of performing the works, geological works. And the legislation, and you can see the organizational chart of geological agency of the Kyrgyz Republic. There were changes in organizational chart, as I met. The SOE, state-owned enterprise, we have 55 staff members, but including with their affiliates, we have more than 2,000 staff. Main objectives of the geology to implement and perform economic activities, the public policy in geology, coordination of different programs and projects to improve and increase the mineral base of the Kyrgyz Republic. Today, there are a total of 22 projects implemented based on state contract or public order. In hydrogeology is the main projects are implemented, including the geological expedition. So that enterprise or the projects aimed at water supply of agricultural facilities and monitoring of hydrogeological areas. Second, analysis and analytical work, in-desk review, expeditions, maps, drafting different layout plans. With Uzbekistan, Kazakhstan, and Tajikistan, we continue our cooperation. Accounting for and storage of biological materials. We have our own museum, by the way. It's the only museum in the country. It's called paleontology area. Our SOE also implements practical activities as well, such as the data collection and so on. And the South SOE or the expedition is working on processing or developing geological fund. SOE, Kyrgyz Geology, now is eligible to enter into agreements with different companies today. We have 18 signed MOUs and agreements with other companies and 13 draft agreements are underway on deposits. So these deposits are of metal, gold, coal, and other placers, deposits. We regularly contribute different opinions, views, and we provide our input to amend the laws and legislations. We are the members of the working groups to develop the strategy of mining sector of the country. And in addition, we are working now on drafting the mining code. The goals of Kyrgyz Geology is to provide services to state-owned enterprises and private sector, including the contribution to mineral resource base based on index reviews, and of course, payment of taxes to the state budget. The main activities of the SOE and the goal of my presentation is to implement the measures represented in the national plan on extraction of polymetals and rare earth metals for dynamic development of the economy of the Kyrgyz Republic. And this is the decree of the president. It used to have another name, critical materials for the economy of the Kyrgyz Republic. Given that we have no definition on critical materials, so we agreed that it will be extraction of polymetals and rare earth metals. To implement this decree of the president, we have issued separate bylaw as of March 2024, which provides for the main key stages, to be implemented to implement this decree on polymetals and rare earth metals. First, provides to explore polymetal deposits only is implemented by SOE, Kyrgyz Geology, and second, cooperation with technological companies on extraction, jointly with Kyrgyz Geology and Kyrgyz Altyn. Communication and information counseling is implemented jointly with other ministries, and ours. Capacity building is the next area. Implemented by Kyrgyz Geology and the Kyrgyz Society of Subsoil Users. And of course, allocations from the national budget, which is done by the Ministry of Finance, which I hope will be faster. So why we need critical raw materials as CRMs? It is more related to public servants. Let me skip this slide. But the only thing is very important element, CRM. Let me cut some slides. So countries accounting for largest share of global supply of CRMs, these are China, Russia, and by some other components with other countries as well. As a part of critical metals map Central Asia, I welcome you to learn more on our website. Oxford Institute, So CRMs in Central Asia. As a whole, the mineral inventory comprising more than 2020 deposits based on the major and minor commodities allows mineral assessment of the critical metal potential, which is very intense and important. CRM in the Kyrgyz Republic is represented by 4 components: antimony, raw materials, and partially copper. Other components are not so important for critical materials. Within this study is so-called rare raw materials. SOE, Kyrgyz Geology, has a license to develop Kutisai deposit. Is a deposit which had been developed already in the past. Back in 1960s, last century, it was closed. Now we are relaunching our operations. Out of sheet ores. Today, Kyrgyz Geology have re-digged out 30 deposits, which were decreased up to 30 times. After calculation of deposits or reserves, we'll provide additional information now. So it is changing the status of the deposit from closed, and we start working on impacting environmental risks, given that that deposit is somewhere natural protected area, the forest area. So soon the deposit will be redeveloped Another important part of rare earth and anthropogenic resources is the state enterprise hydrology, rehabilitation, and putting to critical abundant Kyrgyz mining and processing. So KMPP starts in operation 1944. So the main products of the plant was urium, and there are 4 tails at the moment. So these are the village, Actus and Bordeaux villages. The total amount, the total volume of the tailings is 3.7 million cubic meters of the 130 square meters with 15 natural resources. And the minimum estimation of mineral reserves is PBE 23,000 tons of CN, zinc 40,000 tons, AG for 46.5 tons, iron 1.5 tons, copper is about 3,580 tons, and others, while the average size of the noting particles is 0.17 millimeter with density of 1.65 gram cubic meter. So everything is ready to redevelop them. As of now, we are performing environmental, ecological, social cleaning, I would say, mitigation. Economic goals are to create new jobs, investors, attraction, human capacity building, and bring in line with the Kyrgyz legislations. International standards include. So, our performance or our work is to bring in line with best international standards. And soon we are expecting changes to the law of the Kyrgyz Republic. So given the tails processing or redeveloping is very limited in terms of legislation, so the life is changing soon, so we are going to amend those laws. Environmental goals, of course, to better manage the tailings, recultivation of the tailings, environmentally safe technologies. I'm actually done. Thank you so much for your attention. All those who had interest to these projects have contacted me already, so we'll continue our consultations. I didn't say anything about the 3rd deposit. Recently, we have performed, you know, that we have a lifting of ban. We have lifted the ban on uranium developing. Kozlatu deposit will be presented separately as an investment opportunity. Thank you for your attention.